So now we are going to discuss about segmentations in OS. So the paging and segmentation is a non-contiguous memory allocations. So in paging techniques, each and every process can be divided into number of pages. So why do we go for paging? So the process, suppose if we take one process, the size is 10 GB of process. So the main memory is 4 GB only we are having available. So if you want to execute 10 GB of 10 GB of process in main memory locations in the 4 GB only available. So it is not possible to execute 10 GB of process in 4 GB of memory locations. So then only the process can be divided into number of pages. So each and every pages will have some small number of size, so we can execute in the memory locations accordingly. So segmentation, why do we go for segmentation? So segmentation to implement modular structures. So but in the paging we are not maintaining any modular structures. So modular structure means each and every functions, each and every in the main memory location, each and every partition will have only one functions we have to maintain. But in paging, the same method applied in different pages of the process. So there is no maintaining any modular structures in the paging. So to overcome these paging techniques, we go for segmentations. So in paging, the main problem is same method occupy in different pages of the process. So on different frames of main memory locations. So and also segmentation is a non-contiguous memory allocation. Non-contiguous means non-contiguous memory allocation means wherever the free memory space is available on the main memory locations, so it will be allocated to the segments according to the free space available on the main memory locations. So in the contiguous memory allocation means the only the single block of memory allocated to the corresponding process, but non-contiguous, wherever the free space is available, it will be allocated to the particular segment or the process. So we are having two types of segmentations. First one is virtual memory and simple memory. So virtual memory segmentation means it divides the process into number of segments, but the process cannot be loaded at the runtime of the program. But in the simple memory segmentations, each and every segment of the process will be loaded at the runtime. So for example, if we take on C programming for modular structures, in C programming is a collection of functions, and then in the collection of function, each and every function will execute a particular statement. Suppose if we are having a deposit, withdraw and cancel function, three functions available. So the deposit function may have a different pages of process, at least 10 pages if we let us assume, and then withdraw function may have a 15 pages of the process, cancel function may have a 20 pages of the process. So the deposit may occur in 10 pages of the single function may occur 10 pages of the process. So the same method is repeated in main memory locations. So it is overcome this problem, we go for segmentations. So segment table, what are the contents available on the segment table? In segment table, if we take segment table, the table stores information about all such segment is called segment table. It is a two-dimensional logical address. One is logical address, and creating CPU will always create a logical address, and in order to execute particular process in the main memory locations, we need physical address also. So the base address, it contains starting physical address where the segment reside in the memory. So the segment table contains both base address and the limit address. So next one is the diagram of the segment. So the CPU here, the CPU is create a logical address. The logical address is divided into two types. One is segment and then offset address. So offset address here indicating D indicating the offset address. So wherever offset address means each and every instructions where it is located, the particular location of the instruction is called offset address. Here in the segment tables, limit and the base address. So offset is less than the limit of the segment. We can access the valid instructions. If we want to access the instruction in the memory locations, we need offset is less than the limit. When the offset is greater than the limit means we cannot access the particular instruction on the main memory locations. So whenever the offset is less than the limit, so the condition is true, that means yes, and then we pass the instruction to the main memory locations. So here we are adding base address plus limit address. We are creating a physical address on the main memory. So whenever the base address is greater than the limit means the OS will create an trap or interrupt. So after that we have to find out the base address of the main memory locations. So if we want to execute one instructions, we need to adding both logical, that means we are converting logical address into physical address. So for that we are using the memory management unit, MMU. So that means what is the next what is the advantages of the segmentation? So there is no internal fragmentations and flexibility, and then sharing resources, and then advantage and disadvantages means a process are loaded and removed from the memory. The free memory space is broken into little pieces, causing external fragmentation and overhead. The use of segment table can increase overhead and reduce performance. When we are using segment table, it will create some reducing the performance of the CB utilization, and due to need for two memory access, so one for segment table and another for main memory access. If we want to access one particular instructions, we need two memory access. One is for segment table and another one is accessing for main memory. So this is the main disadvantages of the segmentation. So these are the overall view of the segmentations. Okay, thank you. Management and then information maintenance and